Let's turn our attention now to a very important rule known as L'Hopital's rule. Now, the objective here is first to be able to identify indeterminate forms, and we've actually looked at several indeterminate forms. We've seen them before, and what we've done before, we've said that, hey, if this particular function is an indeterminate form, then we knew that simply was telling us that we needed to do more work. That more work quite often can now be dealt with L'Hopital's rule. So we want to properly apply L'Hopital's rule when calculating a limit, which results in an indeterminate form. L'Hopital's rule applies to taking limits. So let's take a look at indeterminate forms, and just a quick review. 0 over 0 is an indeterminate form. Infinity over infinity is an indeterminate form. These are not equal to 1. I know that anything over itself equals to 1 except for 0 and infinity. 0 times infinity is an indeterminate form because 0 times infinity actually, you'll see in some examples, turns out to be essentially the same as infinity over infinity. And infinity minus infinity. These are most common indeterminate forms that we're going to be dealing with. So first of all, let's take a look at a real quick example here to kind of motivate the idea behind L'Hopital's rule. If I take a look at this limit of x equals 1, I see a polynomial divided by a polynomial. First thing I'm going to do is I'm going to try to evaluate this at x equals 1. When I do, I get 2 minus 2, which is 0, over 1 minus 1, which is also 0. This is an indeterminate form. So what we do now is we go ahead and try to take a limit using some other techniques. Now, I would take the limit as x goes to 1. If I factor out this 2, I get 2 times x squared minus 1 over x minus 1. Well, that equals a limit as x goes to 1 of 2 times, factor out the x squared minus 1, which is, x minus 1 times x plus 1 divided by x minus 1. These guys cancel out, and I end up with a limit as x goes to 1 of 2 times x plus 1, which equals 2 times 2, which is 4. So I would say that this is the limit. So I saw that I had an indeterminate form that told me I had to do more work, and I did a little bit more work. This case is a simple matter of factoring and canceling out the denominator, which gave me 0 in the denominator. And then I figured out that limit was exactly equal to 4. And this is what you would be doing up until now. And now we're going to apply L'Hopital's rule. Which will make this, this process much easier.